Okay, so this is question 7 for page 141, the dynamics unit. It says 2 figure skaters are moving in the east together during a performance. Skater 1 will label as mass 1 is 78 kilograms, whereas skater 2 will label as mass 2 is 56 kilograms. It says skater 2 pushes on skater 1 with a force of 64 newtons, again, in the west direction. Assume no friction. How lovely. We don't have to deal with that. And it asks to determine the acceleration of each skater individually and what is essentially happening to the motion of each individual skater. So we'll kind of delve into what that kind of looks like. Our force applied, of course, is 64 newtons as skater 2 is applying that force onto skater 1. And then, of course, we have our masses. We'll create a reference frame, and we'll label east as positive and west as negative. It's a little wonky. And then we'll kind of look at a diagram to almost put it into a better perspective of what's essentially happening here. So, of course, mass 2 is applying that force applied, 64 newtons. It's going in the west direction. And we have a force of 1 acting on 2 and a force of 2 acting on 1. Because there's 2 forces acting on one another, they do essentially cancel out. It's like adding -1 with +1. It equals 0. So they cancel out. And that's essentially, these forces are acting on one another because there's 2 bodies in a system pushing against one another. It's the same value. It's the same force. It's just both negative and positive. So again, they cancel out. If we want to be more proper, we can always say that there's a force of gravity acting on 2 and a normal force acting on 2. Likewise, there's a normal force acting on 1 and force of gravity acting on 1 as well. But these really do all just cancel out. Plus, we're working with a horizontal direction in this question and not a vertical direction, so it doesn't really matter regardless. And that means we're honestly just left with a force applied of 64 newtons. So let's start looking at how we can solve acceleration. So let's look at how we can do it for skater 1. If we use force equals mass times acceleration equation and isolate for acceleration by dividing out mass, then we get A equals F divided by M. But make sure, because acceleration and mass are different values in skater 1 from skater 2, let's add our subscripts. Acceleration of 1 equals force divided by mass of 1. The force has no subscript because the number stays consistent throughout. It doesn't change, therefore, it doesn't need a subscript. Now we can plug in our values. So acceleration equals -64 newtons because it's being pushed in a negative west direction. And then we can divide that out by 78 kilograms, and we should get a number of approximately -0.82051 meters per second squared, because it's a negative number. That means it's moving in the west direction. Wait, that was wrong. 0.82, round to 2 significant figures because our givens were, in 2 significant figures. So it can just be 0.82 approximately in the west meters per second squared in the west direction. There we go. So there's our acceleration for skater 1. It's being pushed in the west direction, therefore it's moving in the west direction. Now we can follow a similar approach in solving for the acceleration for skater 2. Isolate for acceleration using our force equals mass times acceleration equation. Again, subscripts. Acceleration of 2 equals force divided by mass of 2 because they are different values again. So we plug in our values. This time it's 64 newtons instead of -64 newtons. And then divide that by the mass of 2. And we should get approximately 1.142. That's the first three numbers after the decimal. And because it's a positive number, it means it's moving in the the east direction. And there we have it. Now, why is it that skater 2 is pushing in the west direction, but they're accelerating in the east direction? How does that make sense? Especially if skater 1 is accelerating in the west. Why are they moving in different directions, though the force is only being applied in the west direction? Well, this can kind of be explained by Newton's third law, which kind of looks at action-reaction forces. Newton's third law states that for every action force, there's an equal but opposite reaction force. And that's essentially what's happening in this case. With mass 2 pushing on mass 1, that reaction force pushes mass 2 back and accelerates mass 1 forward. If we put this into maybe a more conceptual situation, we can think of when we're riding a bike. In order to move forward, to accelerate forward, the wheel has to move backward, and that's done by pushing the pedal forward. So if we connect this back to the skaters, the skater 2 is pushing skater 1 forward, which ends up accelerating her back in the east direction, but it does accelerate skater 1 in the west direction. So think of it as the wheel faces that action force of moving backward, but reacts by accelerating the girl forward. So in this case, skater 1 moves forward, but because skater 2 is pushing forward, that reaction force accelerates her back in the east direction.